Hello friends, this video on structure of atom part 30 is brought to you by examfear.com. No more fear from exams. Before watching this video, please make sure that you have watched part 1 to part 29. Now we'll talk about magnetic quantum number. It gives the information about the orientation of the orbital. Till now we have seen the L, the azimuthal quantum number gives the shape of the orbital, whether it is a S shape, P shape, D shape. This guy gives the orientation of the orbital with respect to coordinate axis. For a given subshell or L, I can have 2L plus 1 values of M. That is minus L minus 1 L as 0 to L. I'll explain that. For example, value of L is 0 here, right? That means S, so number of orbitals is 1. This guy is 1, so I can have values from minus 1, 0 and 1. Number of orbitals is 3. This guy is 2, I can have values from minus 2, minus 1, 0, plus 1, plus 2. How many? 5. This guy is 5. So that's how it is. So if you see, this is my S orbital. For S orbital, there is only one shape. Then I have P orbitals. For P orbital, I have 3 shapes. 1, 2, 3. 3 orientation actually. For D orbital, if you see, I have 5 different orientation. 1, 2, 3, 4, 5. I'll explain in detail for all these. Just understand that for S, there is only one orientation. For S, there is only one orientation. For P, there are 3 orientations. For D, there are, because this is S, this is P, this is D. For D, there are 5 orientations. Similarly, for F, there are 7 orientation. And continue. Magnetic orbital, let's take an overview now. For example, this is my P orbital. So if you see the way it is done, this is Px, which is where it is inclined to x. Py, because this guy is in y-axis. This guy is Pz. We have P orbitals in 4 different shapes. This is one where everything is combined actually. All Px, Yz is combined. And if you see, this is 1s, 2s is bigger, Px is this way, Py is along y-axis, Pz is along z-axis. Similarly, if we talk about D, so D, if you see, for D we had 5 different orientations. This guy is dyz because yz is the plane where I have this orbitals. This is dxy because xy is the plane where I have this orbitals. This is dxz because xz is the plane where I have this orbitals. This is dx square minus y square, x and y in like this fashion. And this is dz square because along z axis. So these are 5 different orientation of the d orbitals. Similarly, for F also we have, for F I think we have 7 different options, and this is how the 7 different orientations are there for F orbitals. Right? If you see, all are F orbitals, but their orientation is different. So magnetic orbital number will determine the orientation of this orbitals. There is something called electronic spin also, as I told, right? Each and every here my orbital will have 2 electrons. This guy will have 2 electrons. Maybe this guy will have, everything will have 2 electrons. This whole thing will have 2 electrons somewhere. Only 2. This is one orbital. This will have 2 electrons. Somewhere, maybe both are in the same area also. You don't know, right? Each and every will have 2 electrons. Jumping and pumping around here and there. Right? So, since there are 2 electrons, each may have different spins. In fact, both will have different spin, one clockwise, one counterclockwise, and that is denoted by spin quantum number. So 3 quantum numbers which we have got: n, l, and n. Principal quantum number, azimuthal quantum number, magnetic quantum number. They are not sufficient to predict the atom. They are sufficient to predict the, or to pinpoint the orbitals. Right? With n, l, m, L and M, we can tell which orbital it is. But in orbital, we have 2 electrons. So we can't tell which electron we're talking about. So we have a more quantum number called spin quantum, right? All these quantum numbers are not enough to explain the line spectra, which is observed in the case of multi-electron. So we have this third, quantum numbers, because to find the exact electron we need the fourth attribute also. So this guy in 1925 proposed the presence of fourth quantum numbers, that's called electron spin quantum number. It can have two values, +1/2 and -1/2. That's all. So you see, electron spins around its own axis. It can be clockwise or anti-clockwise, and that's what it is denoting. So if you see, it's a plus up spin or down spin, and the values is +1/2 and -1/2, because electron spin, this electron, it spins also, right? It can be either clockwise or anti-clockwise. Only two options it has. Now, orbitals cannot have more than 2 electrons, and these 2 electrons should have opposite spin. Please note, one orbital I have told already cannot have more than 2 electrons, and these 2 electrons should have opposite spin. At the max 2 electron, it can have 1 electron also. The valence electron orbitals generally have 1 electrons. So let's understand the quantum number tree view. So let's suppose we'll start from here. So we have quantum numbers, right? So it can have a value of n, can have, I'll say n here, n can have a value of 1, it can have value of 2, it can have value of 3, or it can have value of 4 also. Correct? If n is equal to 1, my L can have value only 0, because it has to be 0 to n minus 1. Here, n is equal to 1, L can have two values, 0 and 1. If n is equal to 3, n can have three values, 0, 1 and 2. So for 4, my L will be 0, 1, 2 and 3. 3 possible values for L. If you talk about M, for L is equal to 0, M can have only one value, 0. For L is equal to, okay, for 0 can have only one value. For 1, it can have three values, -1, 0 and +1. Here also if you see, for 0 it can have only one value, 0. For this guy, -1, 0 and +1. For 2 also it can have 5 values now, -2, -1, 0, +1, +2. Like that it will continue. Here also we can continue. Now I have something called spin quantum number, right? This is called spin quantum number. So for this I can have two values, +1/2 and -1/2. In fact, for any of these I can have two values, +1/2 and -1/2. For each of these, right, I'll have two values, +1/2, -1/2, +1/2, and that is how the T structure for a quantum number. That means for a given number like this, if you take this path, right, I can tell one electron. For example, if I know this, and this, these four values will uniquely give a particular electron, and these three values n element will give a unique orbital. Correct? So let's take a summary for the four quantum numbers which we have just studied. You have something called cells, subcells and orbitals. And this n defines the cells, also it determines the size, and to a large extent the energy. And there are n cells in the nth, n subcells in the nth cell, this I have done. And there L identifies the subshells, also the shape of subshells. So L is something which defines that. And then we have orbitals, right? And the orbital is nothing but 2L plus 1, the number of orbitals we have. For example, for S I have one orbital, for P you have 3 orbitals, for D you have 5 orbitals, and so on. L also determines the energy of electron in multi-electron atom. So the rules are complex, but for our understanding we can say that N plus L will determine the energy of an orbital. The one with higher value of n plus L will say that that has both energy. And this magnetic quantum number designates the orientation of orbital. So for a given value of L, my ML has 2L plus 1 values, right? And MS refers to orientation of spin of electron. This is what we have studied. We'll take some examples. What is the total number of orbitals associated with quantum number 3? So let's take this. If my n is equal to 3, my L can have value 0, 1 and 2. Right? I have to find number of orbitals. So my P, for 0 I have only one orbital. For this guy I have orbital minus 1, 0 and plus 1. For 2 I can have orbitals minus 2, minus 1, 0, plus 1, plus 2. So if you add how many orbitals I have got, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 orbitals I have got. Also I can use the formula directly. N square is nothing but the number of orbitals. So n is equal to 3, I get 3 square, that is 9 orbitals. So you can use any of these. Correct? But understand both the method because this clears your concept. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.